Okay, so 42, make array consecutive 2. Now that sounds kind of familiar. Why does that sound so familiar? Oh yeah, I remember why. This was the first task ever done on JavaScript the game. This was the first one ever. So it holds a special place in my heart. And yeah, we've got our buddy Radiorg here. He got statues of different sizes as a present from Codemaster for his birthday. Each statue having a non-negative integer size. Since he likes to make things perfect, he wants to arrange them from smallest to largest so that each statue will be bigger than the previous one by exactly 1. He may need some additional statues to be able to accomplish that. Help him figure out the minimum number of additional statues needed. Cool. Let's do this. So, how should we do this? I guess we could probably think of a few strategies. I actually don't really remember what we did the first time or the second time we did this problem. This appeared in the intro, and it was also one that I did as kind of like a pilot, just as a test to see if this was something I was going to continue doing. I did 2 of these. I did 6 and 7 from the intro, and the rest is history, as they say. Anyway, let's keep going with this. So, wait, the math trick? There's a math trick? Well, don't tell me. We'll see if I know it. I probably don't, but we'll see. Anyway, as for now, let's start with, I'm trying to think what would be the best way of doing this. One way we could do it is just to sort it first, right? So we could just say, like, statues.sort. Yeah, we haven't done a sort in a while. It's been a while since we've done a sort. We could do this manually if we wanted to. There are lots of different kinds of sort algorithms, and actually that's one of the coolest things to visualize in programming. So there are lots of cool YouTube videos. You go to visualgo. Is it .com, .net? I'm not sure. Visualgo.net. Yeah, and we could look at some cool sorting algorithms and stuff like that. So try this new module. While we wait for that to load. Oh, okay, that's loading. So yeah, let's just escape that for now. We can choose what kind of sort we want. It could be bubble sort, selection sort, etc. We got all kinds, and we can sort of play this back, slow or fast. Is it playing or no? It says it's paused. Sort. Wait. Oh yeah, there we go. Cool. So it started doing its thing. We can speed that up, make it go fast. It's kind of neat, sort of a cool thing to visualize. So this is, I think, sort of the most straightforward way of doing this would be a bubble sort. But there's some other pretty neat ones that I think this is one of the more popular ones. Merge sort, as far as I understand. Look at that. Oh, cool. Anyway, when we just do dot sort, like we were doing in the codefights window a second ago, as far as I understand, and if anyone knows better than me, let me know. I'd love to hear it. As far as I understand, basically we have a JavaScript engine that's running in the browser. So when it sees like a dot sort, it has an implementation, like a sorting implementation that it goes to do that. And I believe it's merge sort. So I'm pretty sure the complexity is like n log n. I could be wrong about that. So if anyone knows, yeah, let me know. We can't just do sort on this thing because these are numbers that we're dealing with. By default, it's going to order these in lexicographic order. So if we don't want that, then we need to do something like this. And that seems kind of strange, like we would expect it to be something like, if you think of like a filter or other kinds of higher level functions that take a function as an input. Usually it's that we're returning like a true or false, and like for example in this case, if it's true, flip them. If it's false, don't flip them. That sort of thing, right? But in this case, what we actually do is we give it either a positive number or a negative number, and it uses that to determine whether it should flip them or not, whether it should switch them or not. So in this case, let's just return statues because this is another mutating method, another one of those in place things. Okay, cool. So this gives us a sorted array. It's what we're looking for, right? So what we want to do is basically figure out how many of these guys are missing. So how are we going to do that? Well, I guess we'll say let missing be assigned the value 0. We're going to be optimistic and say right off the bat, let's assume none of them are missing. Yeah, it's a perfect world. None of the statues are missing. Wouldn't that be nice? And then let's actually investigate and see how many of them actually are missing. So we'll say for let I be assigned the value 0, I is less than statues.length I plus. And you know what? Let's start this at 1. Yeah, let's start this at 1. Okay, cool. And the reason we're going to do that is because if this was perfect, if none of these were missing, Radiorg would be very happy, and basically it would just be like 2, 3, 4, 5, 6, 7, 8. Nothing missing in between. So what we should expect is that for each element, we could have a situation like this. Statues at I minus statues at I minus 1. Okay, so current element minus previous element. It should be 1. Right? If it's anything bigger than 1, like in this case, 6 minus 3, that's 3. That's not 1. It's 2 bigger than 1, which means there are 2 elements missing, right? 4 and 5. So we could do something like that. We could do this difference. So statues at I minus statues at I minus 1 minus 1. That's how many are missing. So let's actually just add that to missing. Missing plus equals all that. And then at the end, let's return missing. Let's try that. Does that work? Yeah, it works. Great. Let's see if it passes all the hiddens. It passes the hiddens. Awesome. Okay. Hey, we're getting pretty close to that next level. Whew. All right, we'll close that for now. Oh, level complete. Look at that, 4,000 coins. That's nice. That's very nice. Okay, thank you. All right. Great job. So yeah, that's a way we can do it. There are other ways we can do it. Is there a way we could do it without sorting? Yeah, probably. So let's do that. Let's get this out of here. We're going to reset the code. And yeah, it's already ending with a 2, so it might look weird if I put a 1. I'll just put the word cool, just so it's different. Okay, so for this one, let's do something a little different here. We'll say const length is assigned the value of statues.length. And then we'll say const min and max are going to be assigned the values of statues. Let's just do it like this. Yeah, math.min of statues and math.max of statues. And remember, we've got to do a spread operator for these because otherwise it's just going to look at that and say, well, you want me to take math.min of a single element and that element is just an array? On multiple levels, that doesn't make sense. Whereas instead, when we put the spread operator, we're saying, I want you to find the minimal element in this array. Oh, it makes a little more sense. Okay, so now we'll just return max minus min. Wait, max minus min? Is that what we want? Let's think about what we want. So in this case, we're looking at these numbers. Let me get a pretty sick color. Okay, cool. So this is like 2, 3, no 4, no 5. We've got 6, no 7, but we have 8. Okay, so let's put in the missing elements here. So 4, 5. Ooh, how do you like that color palette? Reminds me of the 1980s. Anyway, okay, cool. So basically, if we look at this, then 8 minus 2, that would be 6. 6 is very close to the number of statues we have. So what we actually want is like the max minus the min plus 1, and that'll give us the total number of statues that we want to have, right? So let's do that, okay? So we'll do, yeah, what was it again? Yeah, max minus min plus 1, okay? So 8 minus 2 plus 1, that'd be 6 plus 1, 7. There are 7 elements here. That's great. And then from there, well, how many of these elements do we have, right? So we'll get the total number of elements, which is going to be max minus min plus 1. And then we're going to subtract from that the number of elements we already have, and that should give us the missing ones, right? So basically, we'll say, all right, we got all these guys. That's 7. And then we'll subtract 4 from that, just the length of this, right? The number that we have already. That gives us 3. 7 minus 4 is 3. Okay, great. That's all we need. So max minus min plus 1 minus length. Okay, so in other words, this is how many we have. This is how many we want minus how many we have. Well, that should give us how many we're missing, right? In fact, let's just be clear to the reader. So how many we have is going to be max minus min plus 1. It's nice to be clear to the reader, right? Whereas, wait, that's not how many we have. That's how many we need. How many we need. Okay, and then okay, how many we have. Yeah, okay, that's going to be length. In fact, let's just make that statues.length, and yeah, we don't really need this, right? Yeah, so we've got min and max. How many we need is this. How many we have is this. And then how many we're missing. Almost put an apostrophe in that one. It's going to be how many we need minus how many we have. And then we're just going to return how many we're missing. Okay, so maybe I'm going a bit overboard on these variable names here, but hey, it should be really clear to the reader, huh? Okay, so let's see. I'll try testing this with the hidden tests. And in the meantime, I think I missed a few comments here. So ATD says, this is a much better way to solve this problem. I think the way I did it was initializing a count variable using math.min and max to get all the values between them, and then seeing if -1 is a result using index of comparing the original array. Right. And yeah, I'm pretty sure my first attempt involved some kind of index of stuff. But yeah, I don't know. ATD. Yeah, okay, I think Rainbow basically just described what we just did. Was that the math trick you were talking about, Rainbow? Because if so, I guess maybe I did know it. Is there a better way to do this? I can only really think of one. Yeah. And it's really subtle. I don't know. No, it would really not make a difference here because the length of this thing is at max 10. What I was going to say is basically one thing we could do for this is for the min and max. Technically, this is going through the array twice, right? Like it's going through once to find the minimum, going through again to find the maximum. So if we can make it in such a way where like it just runs one loop through the array and identifies both the max and the min in that one loop, then that's probably better. But I think I did that the first time around. So, you know, watch the VOD if you want to see that. Today we're going to do something different. Yeah, we're going to do something different. So specifically, I want to use like a map or something for this. So for min and max, I want to do something like this, like math.min and math.max. Yeah, something like that. You might be looking at it and thinking, what? How? You know, like this is just two functions. Does that even make sense? And then I'm going to do a dot map on these things to say, I'll call it func. Okay, that's going to be the input here. So it's either going to be math.min or math.max. And we're going to do func of spread statues. Okay, that's what I'm saying. So let's see if that works. Does that work? Yeah, that works. So this is kind of cool because we can actually use the function itself as like one of our inputs here, right? Like one of our arguments. And then instead of like doing a function to the input, we're actually using the input as the function and applying that to something else. So that's kind of like flipping the chessboard a little bit. It's kind of a neat way to think about it. So, okay. Rainbow says sorting is more efficient, it seems. Okay, cool. Did you do like a JS perf or something like that? When I think about it, technically it shouldn't be, but maybe it's just because like these are so small. You know, like if this could be, if this was like 100,000, I think we'd see more of a difference here because, I mean, look, this is only going to go through the array 2 times, right? Whereas this, the amount of time it spends is going to scale up non-linearly according to the size of the array. So yeah, intuitively, I would say this one should have at least a better time complexity, but that doesn't necessarily mean it's going to be faster. I'm wondering, could we do this differently? We probably could, you know, we could probably use like a width or something like that. Or, hey, we can, I think, do something like this. I could be wrong about this one, though. So making a new variable and just making it the object math. Would that work? Okay, yeah, so apparently that would work too. I don't know if that's better. So Rainbow's asking, doesn't that way create an array? This way over here, you mean? So are you referring to like this array over here? Because this array is only 2 elements long. So because of that, it's not going to scale up. Like the complexity of this won't scale up according to the size of the inputs. Regardless of the size of the inputs, this would just be 2 elements long. And furthermore, because we're using a destructuring assignment, I don't think it's going to actually retain these in memory. Like it's not going to have any variable names pointing to them. So I'm pretty sure these would get picked up by the garbage collector. At least that's my understanding of it. Okay, cool. So let's submit that. Good. It's working. Cool. Nice job, everyone. Let's get out of here. Okay, so